Part 2, Chapter 6, Time Value of Money, Bond and Lease Payments, and Future Value. Now again, we are going to use one of these three. We either use present value when we have a single sum at the end of a period, or if we have multiple payments of the same amount and the payment is due at the end of the first period, we use the PVA table. Or we use the PVAD table if the payment is due at the time of the contract sign or right when the contract begins. So remember to pay attention to when payments are going to be made. So we're now going to look at a couple examples. So here we're going to look at issuing bonds. So we have a bond issued, has a stated rate of 8%, has a face value of $300 million. The bond matures in 20 years. The market or effective rate is 10%, and they pay interest semi-annually. Determine the cash proceeds and the first bond payment. Well, what do we need? First of all, we need to know the face of the bond, which we know is $300 million. We need the stated rate. This is the rate that you're always going to use to figure out the cash payment for interest, and it's going to be that interest rate times the face of the bond divided by the number of payments in the year. Effective rate. This is the rate you're always going to use when you go to the factor tables. And it's going to be the rate you use if you're using the effective rate for calculating interest payments. It's always going to be the rate divided by the number of periods in the year. So in this case, if it was 5 years, we'd have to divide by 2. If it is paid semi-annually, we'd have to divide by 2 to get the rate that we're going to look in the table for. And then number of periods is always going to be the years times payment in the year. So again, if it's 5 years and they pay quarterly, you take 5 times 4 to be 20 periods. So in our example, it's $300 million, which is the face of the bond, and that's a single payment at the end of 20 years. And the number of periods is going to be 20 years times 2 because the interest is going to be paid semi-annually. The stated rate is going to be 4% because it's paid semi-annually, and the rate is 8% on an annual basis. And to come up with the annuity payments, we're going to take the face of the bond times the stated rate, divided by 2, because semi-annual payments. And the effective rate, we're going to take that divided by 2, and that's going to be the factor we use when we go to the tables. So remember, this is the factor you're going to use when you go to the table. So now we're going to go to the present value table and get the factor to come up with what the present value of the $300 million is. And then we're going to use the present value of an annuity table to figure out what the $12 million payments for 40 periods is worth in today's dollar. And our effective rate is going to be 5%. So we're going to have to go to 2 different tables. Now again, remember, interest is normally stated as an annual amount, so if you've got multiple payments during the year, then the interest rate used for the tables is the rate divided by the number of periods in the year times the number of years. So here's our present value table. We're going to go down to 40 periods, and then we're going to go back across to 5%, and there's our first factor. Now for the multiple payments of interest of $12 million, we're going to go to our PVA table. We're going to go down to 40 periods and across to 5%, and there's our factor for our $12 million. And now we can see what is our cash proceeds. We're going to take the $300 million times the first factor, and we're going to take our $12 million times the PVA factor, and that tells us our cash proceeds for our bond. Now, since it's less than face, that means this bond was issued at a discount. What's our journal entry? Well, bonds payable is going to be $300 million. Cash is going to be the $248,524.80 that we came up with, and the difference will be discount on bonds. What does our first interest payment look like? Well, the cash is going to always be the face times the stated rate divided by 2 since it's semi-annual. The interest expense is always going to be the balance of bonds payable, which is always going to be the face of the bond, $300 million, minus the discount on bonds. For the first payment, it's always going to equal the cash received times the effective rate divided by 2. And then you're going to subtract these to reduce our discount on bonds. Now, what about a lease payment when the payment is made at the end of the year? So now we've got here 20 years, $200,000 annually, and we're going to assume that they can borrow at 6%. 20 periods, 6% is our factor. Our annual payment's $200,000. And the first payment is at the end of the first year. So that means we're going to go to our PVA table. We're going to go down to 20 periods, across to 6%, and that is our factor. And that is our present value is going to be $2,293,984 versus the actual cash paid, which means we're going to be paying interest expense over 20 years of $1,706,16. Now, same problem, but what happens if the first payment is made at the beginning of the contract, which is really more likely to happen? Now we're going to use our PVA AD, or present value of an annuity due table, because of the first payment. So we're going to go to our PVA table, PVAD table. We're going to go down to 20 periods, across to 6%. Now we have our factor. We're going to take that times our $200,000, and if you notice, we actually pay less interest if we make our first payment when we sign the contract. Now we're going to look at another what-if problem, and here we have somebody, they have $100,000, they need $100,000 in 5 years, and they can earn 8%, so what should they do? Do a single deposit at the beginning of the first year? Should they make 5 equal deposits at the end of each year? Or should they make 5 equal deposits at the beginning of each year? What is the required amount to deposit? So, what we're going to do for the first one is we're going to go to the present value for a single sum with n equals 5 periods and the interest at 8%, and we're going to get our factor of 0.68058. So what that tells us, for option 1, we'd have to invest $68,058 to have $100,000 at the end of 5 years. Now let's go to our second option. We want to make 5 equal payments with the first one at the end of each year. Now in that case, we'd be doing the present value of an ordinary annuity, and this would be our factor. And in this case, what we do is we divide that into the 100,000, which means that at the end of each year we'd make a payment of $25,046, so that at the end of the 5th year we'd have $100,000. Now our third option is we want to know what kind of payment we'd have to make if we made the first one at the beginning of the period. So the factor we would use, again, we'd go to the present value of an annuity due because of when the payment's going to be made, 5 periods, and we go across to 8%. And if we were to make the payments at the beginning of each year, we would only have to deposit $23,190 at the beginning of each year to have $100,000 at the end of 5 years. Now that concludes part 2 of my presentation on time value of money. Sorry I was coughing a little there, but I seem to have a sinus infection. Thank you so much.